Welcome to the Walton Pi. Today we're going to go through some examples showing how to do integration by parts. Let's suppose that we are trying to figure out how are we supposed to integrate x e to the 2x dx. Well, if we were trying to do this, we are going to have to do this through integration by parts. So we want to choose something that is our u and something that is our dv. Now, the way that we usually choose u and dv, we want dv to be the thing that is easiest to integrate, and we usually want u to be something that will disappear after we take a few derivatives. So if we were to take the derivative of x, that would go to 1. So that tells us we want to say u equals x, and then dv is the rest of it, so e to the 2x dx. From this, we then need to figure out what's going to be du and v. So if u is x, then du is just dx, and if dv is e to the 2x, then v is the integral of that, and the integral of e to the 2x dx is e to the 2x divided by 2. So if we remember the rule for integration by parts, it says that the integral of u dv is equal to uv minus the integral of v du. So that tells us that the integral of x e to the 2x is equal to uv, so that's an x e to the 2x over 2, minus the integral of v du, so e to the 2x over 2 dx. Well, we already know the integral of e to the 2x is e to the 2x over 2, so this is going to be x e to the 2x divided by 2 minus 1/2 the integral of e to the 2x dx. So this is x e to the 2x over 2 minus 1/4 e to the 2x plus a constant c. So this is the integral of x e to the 2x. And we were able to do this using integration by parts. Let's do another example. So let's try and figure out what is the integral of the natural log of x dx. Well, we don't know how to take the integral of the natural log of x yet, so we don't want to say that dv, we don't want to say that is the natural log of x dx, because that's something we don't know how to integrate yet. But we do know how to integrate just dx. So if dv is dx, then we are going to let u be equal to the natural log of x. So then that tells us that du, that is going to be the derivative of the natural log of x, that is 1 over x dx, and then the integral of dx, so v is just going to be x. So from parts rule, so the integral of u dv is equal to uv minus the integral of v du. That tells us that the integral of the natural log of x dx is uv, so x ln of x, minus the integral of v x times du, 1 over x dx. Those cancel, and so we are left with x ln of x minus the integral of dx. This is x ln x minus x plus c. So this is the derivative of the natural log of x. We can't do it directly, but we can do it using integration by parts. Let's do another example. Let's say that we are trying to integrate x squared sine of x. Well, if we want to have u and dv, we usually want u to be something that'll disappear after derivatives, so because we have a polynomial, we probably want u to be x squared, and then that means we want dv to be the sine x dx, so then du is 2x dx, and v is the integral of sine, which is going to be negative cosine of x. So integration by parts tells us this is going to be uv, so negative x squared cosine x, minus the integral of v du, so a negative cosine of x, v du, so times 2x dx. Well, this is also going to be something that we're going to have to do through integration by parts. So for this one, we'll want to say u equals the 2x. So then dv is going to be cosine x dx. So du is just going to be 2 dx. And then v is the integral of cosine of x, and the integral of cosine is sine of x. So that tells us that this is going to be negative x squared cosine x plus uv, so 2x uv minus the integral of v du, so 2 sine x dx. And that is something we can compute directly. We know the integral of sine is negative cosine, so this gives us negative x squared cosine x plus 2x sine x minus 2 times negative cosine of x plus c. So this is the integral of x squared sine of x. And if we wanted to check, we could take the derivative of this and see that it is in fact going to be x squared sine of x. For our last example, let's do the one that often confuses students the most. So let's look at the integral of e to the x sine x. So this is an integral that is of a very common form where we have the exponential times either sine or cosine. And the reason that these are very confusing for students is if we just continue to do integration by parts blindly without thinking of what we're doing, and we're just following the rule, this is never going to end. So, for example, let's say, and so what that means is we have to be a little bit clever in our approach to this. And dv, well, let's pick dv to be e to the x dx, because that is just always going to give us v is equal to e to the x, so that's the easiest one to integrate. And then that means that u is equal to sine x, so the derivative of u is just going to be cosine x dx. So that tells us that this is going to be, so that means that the integral of e to the x sine x dx is equal to uv e to the x sine x minus integral of v du. Well, this one we are going to need to do integration by parts on as well. So for this one we are going to say u equals cosine x, and dv is going to be e to the x dx. So v is just going to be e to the x again, but du is going to be negative sine of x. So that means that we got the integral of e to the x sine x dx is equal to e to the x sine x minus uv e to the x cosine x minus the integral of v du times negative sine x. So that means we have the integral of e to the x sine x is equal to e to the x sine x minus e to the x cosine x minus the integral of e to the x sine x dx. So noticing this, we might be like, okay, I have to do integration by parts again, continue to go through it, but notice that this is the same thing that we started with, which means if we just continued to do integration by parts blindly, we would never finish. However, notice that we have the e to the x sine x dx, the integral of that, on both sides of the equality. So what we can do is we are going to add that to the other side. So moving that to this side, we are going to be given 2 times the integral of e to the x sine x dx is then equal to e to the x sine x minus e to the x cosine x, which means if we want to solve for just the integral, we just have to divide everything by 2. And so that is how we are able to integrate e to the x sine x dx using integration by parts. I hope you enjoyed this video and that it was helpful for you. Please check out some of my other videos, and please like and subscribe if you have not already so I can continue to make these sorts of videos. Have a great day and good luck with the rest of your math.